Wonderful children, whoa, it's good to see you here again. So, all too soon, we are in our 8th week, and today we are going to do something interesting. Today's topic: formation and separation of mixtures, solid, liquid, and liquid mixtures. But before that, I gave you some assignments last week to look at the reversible and irreversible changes. I hope you did it. Some of you did it. You've not sent a picture to me. Others also did. Please try and send pictures to me because we are taking records of all the children who are actually doing the work. Now, with your project work, I would like to commend one girl, Maud Danso. She did awesomely. Perfect work. Honestly, I would like to have that fund that you created and put it on the International World Trade Center so that people will see the work that you have done. And those who are not doing it, I wonder what I'm going to take there. So please do the work and forward it to me. If it is nice, I can assure you, even if I have to take it to United States of America, World Trade Center, so that I'll go and advert it there for you. You can trust me, I'm going to do that. Attention. So, let us delve into today's lesson. But before that, we will look at the answers of last week's question I gave to you before we delve in. Jump with me. All the best. So we are classifying the following activities in the table provided below under reversible and irreversible changes. Question 1. Melting of candle wax. What did we learn last week? We said reversible changes are changes that we can get the actual product back after it has gone through the change. We can get the product back. And then irreversible change is a change that we cannot get the actual product back. As in, after the change has occurred on the substance or the object, we have to get something else. So the first one, melting of candle wax. So candle wax is just like the candle that we use at home when there is light off. So when we melt candle, do we get any other product back? No, we still get candle. So melting of candle wax will be under reversible change. It can be reversed back to the normal candle. 2. Melting of shea butter. So when you melt shea butter, the chemical does not change. You still have shea butter back. 3. Crumpling of paper. So when you crumple paper, you still have paper. There's no new product that has been formed. So it's also under reversible change. 4. Burning of paper. So when you burn paper, you will not get the paper back. So that is irreversible change. Burning of paper. 5. Rusting of iron. So when your iron rusts, it will be difficult for you to get the iron back. I mean, when it really rusts, you realize that there will be some holes in it, and the iron, you will not get it back. So that is also an irreversible change. Number 6, melting of ice. So melting of ice, we established that is a reversible change. When ice is melted, you can take it back to the fridge for it to ice again anytime you want. Heating of water. Heating of water is also a reversible change, simply because when you heat water, there's no chemical formation. There's no new substance that is formed. You still get water. 8. Melting of plastic. So melting of plastic is also a reversible change. There is no new thing formed. You still have plastic after melting it. Burning of wood. So when you burn wood, this is an irreversible change, because when you burn wood, you get ash. You will not get the wood back. Cooking. So we say cooking is an irreversible change. Why is cooking an irreversible change? Now, when you get your corn dough and your cassava dough and you mix them together and you place it on the fire and you begin to stir it, you don't get the corn dough and the cassava dough back. You get something else. You get a new chemical composition which is known as banku. So you don't get the corn dough and the cassava dough anymore. So I hope this is clear between reversible changes and irreversible changes. That is just by the way. So these are the answers. Let's now delve in today's lesson. What is a mixture? So a mixture consists of two or more substances which are physically combined. There are no chemical reactions involved in mixtures. So no new substances are formed. Good. So when you have two substances and then you physically bring them together, not any chemical means, you bring them together and then you stir them, a mixture is formed. Mixtures are often separated by physical means. So because you bring them together physically, so separation will also be done physically. For example, a mixture of sand and water could be separated by filtration. I hope you have heard filtration. If I have water, I get water into my beaker and then I add sand to it. I shake it and I drop it there and I want to now separate these two substances. What do I do? So I get my funnel and then other equipment and I separate it by filtration, which we'll be doing later in this lesson. Sugar and water can also be separated by other means. Classification of mixtures. Mixtures are classified based on how uniform they are and on the particle size of components relative to each other. So we have about two types of mixtures. We have a homogeneous mixture and then a heterogeneous mixture or a heterogeneous mixture. Please take notice of these two words. A homogeneous mixture and then a heterogeneous mixture. What is a homogeneous mixture? A homogeneous mixture is a mixture in which the components that make up the mixture are uniformly distributed throughout the mixture. So, for example, I have water and Coke, Coca-Cola. I hope you know Coca-Cola. And then I add a little of Coca-Cola to water. What happens? What sort of mixture is this? You realize that there will be a uniform mixture. The water and the Coke will mix uniformly. And if I ask you to separate these two mixtures, it's going to be quite difficult. I hope you agree with me. So homogeneous mixtures are uniformly distributed throughout the mixture. So they come together and you are not able to separate the two. You are not able to identify which two mixtures came together to do this. So take notice of homogeneous mixtures. Now, let's look at the heterogeneous. The heterogeneous mixtures do not appear uniform and may consist of different phases. So the heterogeneous mixture can be like milk with granules. Milk and granules. So this mixture, milk and granules, you can physically see the granules in the milk. So please take notice of these two classification of mixtures, the homogeneous and the heterogeneous. Heterogeneous is not uniform. You can actually see the particles like granite in water. You can see the granules. Like sand in water, you can see the sand. Therefore, it is not homogeneous, it is heterogeneous. So let's look at some examples of homogeneous mixtures. Homogeneous mixtures. We say air. Air is a homogeneous mixture. Why is air a homogeneous mixture? Air is made up of different chemicals or gases, but it is difficult for you to see which gases are actually coming together to make air. So please take notice of that. Sugar, water. When sugar dissolves in water, I'm not sure you'll be able to pinpoint that this is the sugar. So this is a homogeneous mixture. Rainwater. Rainwater is made up of different chemicals, but you will not be able to see. Vodka. Vodka is an Italian drink, which is also uniform, just like Coca-Cola. So all these are homogeneous mixtures. Vinegar is also a homogeneous mixture. Dishwashing detergents. So if you have a detergent in your kitchen, for example, Mother washing detergent, you know that Mother liquid soap, or Sunlight. Yeah, these are a combination of chemicals or substances, but they are uniformly added together. They are uniformly placed together. So it makes them homogeneous. Steel. Steel is also a combination of substances which is placed together uniformly. So some examples of heterogeneous mixtures. One, we have cereal in milk. So cereal can be rice in milk or maize in milk. In this type of mixture, you can actually pick one of the substance out from the other. So if I ask you to pick rice from milk, you'll be able to, either using spoon, you can scoop it out from the milk. This makes it a heterogeneous mixture. The mixture is not uniform. It's a mixture where you can see one substance in the other. Vegetable soup. Yes, you can see vegetables in mommy soup. When the soup is boiling, you can see the vegetables going up and down, and you can see them. Pizza. So pizza is also another example of heterogeneous mixture. It is not uniformly done. You can see the pieces of meat or whatsoever that is used to make it. You can see it on it. You can also pick some of the vegetables from it. So pizza is a heterogeneous mixture. Blood. Why is blood a heterogeneous mixture? Gravel, ice in soda, salad dressing, mixed nuts, bowl of colored candies, and soil. All these are heterogeneous mixtures. So this picture is going to give us more light on heterogeneous mixtures and homogeneous mixtures. When you look critically at the picture in front of you, you have mixture. On your left hand side, you have the heterogeneous, and then on your right hand side, you have the homogeneous. And when you look at the substances involved, you have green purples and then a violet purple. So you realize that the violet purples are more than the green purples. Am I right? Good. So this makes it a heterogeneous mixture. These are not uniformly arranged. But let's come to the other side, the homogeneous mixture. What do you see? So you can see that the homogeneous are uniformly arranged. The substances involved are uniformly packed, uniformly arranged, which makes it a homogeneous mixture. We cannot talk about mixtures without talking about a solution. So what is a solution? A solution is a kind of mixture. It is commonly the combination of a liquid and a solid. The mixture is such that the particles of the solid with those of the liquid cannot be separated by filtration. So solution involves liquid and solid, but these two particles, when they come together, we cannot separate them by filtration. So can you give me an example of a liquid and a solid that comes together and cannot be separated by filtration? Think about one. So solutions are formed by mixing solutes in a solvent. That is, a solution is a homogeneous mixture. So far as we cannot use filtration to separate solution becomes a homogeneous mixture. It means that the two substances are uniformly mixed together. We can find a number of solutions in our homes. Here's a brief list. Salt water. Salt water is formed when we mix salt, generally table salt, in water. And then here, water is the solvent and salt is the solute. So when you look at your picture here, solvent is the one that is dissolving the solute. So the solute is the solid, which is going to dissolve in the solvent. So take notice of that. Solute and then solvent. Sugar water is formed by mixing sugar in water. Good. So this is an example of a solution or a homogeneous mixture. A homogeneous mixture. So homogeneous mixture, this is water, the first beaker. You have a water, plain water, and then a sort of ink is dropped into it at the second stage. At the third stage, what do you see? A uniform distribution of the ink into the water, which changes the color of the water. So it makes it a homogeneous mixture. The next thing we have to look at is suspension. Suspension. What is it? So suspension is a heterogeneous mixture that contains solid particles sufficiently large for sedimentation. Suspension is a heterogeneous mixture that contains solid particles sufficiently large for sedimentation. So what we discuss about heterogeneous? We say these are mixtures that are not uniformly mixed. It means that you can actually see some of the particles. And we say suspension is a heterogeneous mixture. Don't forget, so solution. We say solution is a homogeneous mixture, but suspension is a heterogeneous mixture. Now, when particles of solid and liquid are mixed up so that the particles are dispersed throughout the liquid, they are suspended in the liquid. So, for example, if I bring sand and water together and then I mix them and then I shake it, I shake the beaker, or if we are using glass, I shake it and I drop it there, you realize that the particles of the sand will start suspending and eventually they will all settle down. So the particles may be visible to the naked eye, you can actually see them. An example of suspension is a mixture of water and sand. Well, this is a very interesting topic in science, and it's under one of the branches in science known as chemistry. Look, you are going to enjoy this topic so much, and At our next lesson, I will make sure I give you some experiments for you to try at home, and you're going to enjoy it. So engage yourself with this simple activity at home. Try and do it, and perhaps take picture and send it to me. So I wish you all the best. Take care of yourself and be good. Bye for now.